digital twin. What if you can simulate the factory, not even haven't started to build a machine yet? If let's say you can do that, what would be impact?
If you want to know more,
let's Sembang AIoT. Hello, very good morning, good evening, good afternoon, wherever you are. My name is Cecily here.
My name is Daniel.
So welcome to this Let's Sembang AIoT channel again. Yeah. So first of all, we would like to wish our Muslim friend in Malaysia or anywhere Selamat Hari Raya. You know, they are going to celebrate. The Muslim, I know they are celebrating the Hari Raya coming Monday, right?
Yeah,
Monday or Tuesday? Don't know.
Mostly it's Monday.
Mostly Monday. Okay, Selamat Hari Raya. Aidilfitri, maaf Zahir Batin. Okay, so we come back to this Sembang AIoT channel today. Thank you for tuning in. It was a busy week for the past 2 weeks. Yeah, so yeah, it's quite tired. A little bit tired for us. But thank you for watching. Yeah, thank you for watching. So today we want to bring back the topic of digital twin. But before we come into the digital twin, there is something very important about digital twin. It is actually started from a simulation. Just now I asked, what if you can simulate your entire factory before even building a single machine? So actually, by doing the simulation, you can expect what kind of result and things like that. This actually all started from a simulation. But digital twin is slightly different. That's why today we want to, before we touch about digital twin, what are the impact, what are the application. So we want to first talk about what is the difference between simulation and this digital twin. Yeah. So all this while, what do you understand about this simulation first?
Simulation is you have a piece of software. So for example, for those who using those in the electronic industry, they quite frequent use the one called multi-sim. So that one is a simulation software. You can MATLAB
also is also one of them.
Yes.
Yeah. So that is how this what they call the simulation is so important at one point of time. But after when AI come into picture, so more and more kind of forecasting, predictive optimization can be done by AI. So digital twin is actually somehow it started from there. Yeah. So before we go into this this whole digital twin, let's see what are the main differences between both of them. Let's go. So this is a digital twin versus the simulation. Okay, let's go to the part. Okay, when we talk about digital twin, it can be it can be differentiated from 5 areas. One of them is the data. Okay, data. So again, simulation, like what you say, software. You use a software. It's a very hypothetical, or it can be a historical, but it's more of a hypothetical, and usually is driven by a maths formula or mathematical formula. Yeah, so that is a simulation. So where else digital twin would be more of real data and live data. It's depending on the real data and live data. That is the first part. Let's talk about this part, data and simulation and digital twin. So many of us actually we are sometimes confused with this digital twin and simulation. They can't differentiate because both of them very similar.
Yeah, they are very similar.
Very similar. And then if let's say, for example, when we design, Okay, industrial PC design, embedded system design, we usually talk about the heat dissipation. Yeah, heat dissipation. So the heat dissipation actually can be driven by a formula. So by adjusting the input of the heat, let's say it's an input of heat, and then based on this material, there's one constant how the heat is spreading over. So there's one constant, and then the temperature difference between one media to the other media. So these are all depending, it can be formulated using a formula. Okay, so simulation is, I can design the input, I can tell the temperature difference, I can set a constant of this thing. So when I pump in the input, then I know, okay, another point is output lah. So it basically can tell you how this kind of temperature curve at certain point that it can maintain. This is more simulation. So same thing, let's say I want to put this same design, same piece of example, in this case, how to do digital twin. Let's say I have a heat sink from an electronics component, diverting all this heat into the heat sink. And then if let's say I use a digital twin for that, how would that be different? So I'm using digital twin.
Yeah.
So practically, what should I do? Just now I actually basing on formula. Then I can use the software, and then I can pump in this thing. I can get a result, expected outcome. So digital twin.
But for digital twins, you still have the formula, but now this time, instead of you pumping some data, now you are using a real-time data.
Okay, you put in IoT sensor.
Yeah.
You put in more sensor to do that. Then you can it will tell you more of the real. We are collecting all the real data.
Yes.
So by collecting all the real data, then we make it as a virtual.
And then the formula, let's say the formula that representing your devices, that one is not the hypothetical or the theoretical formula anymore. It will contain some of the special characteristics that mimic the real product. So this is something that different from the simulation one. So because every device, impossible is 100% identical one.
Yeah. So that means to say one of them is basing on a very ideal case.
Yes, ideal case.
Okay. The other one is the practical, physical asset that you have.
Yes.
So that data is the one that we build the digital twin on top of that. We collect data and then they put into the virtual model. That is a model that we are doing the experiment on that. Yeah, that's a digital twin. So talking about the second part about connectivity or standalone, there's one spelling mistake. So simulation is normally is a standalone, one system, standalone. But in the digital twin, it can be connected to a physical via IoT. So it's a kind of depending on many factors. Yeah, it's a kind of depending on many factors. So that is more straightforward. Then we come to the third one, feedback loop. I think in the past session we were talking about some feedback and control. So that one is more agentic AI.
Yes,
agentic AI. So I think one day, digital twin, agentic AI, those things may be immersed. Maybe those things may be somehow integrated together next time to do something else.
Yeah.
So digital twin may not be so as what you see right now. Maybe it's a more advanced kind of intelligent digital twin. So digital twin. So feedback and control for this simulation usually is one way. Input, process, output. But in this digital twin, usually it's bidirectional. There is a monitoring and control things element that's going on that we tap on to different data, then we make it into the virtual model. Yeah. So that is a bidirectional part. So of course, when you move on to this complexity, simulation, digital twin, which one is more complex?
Of Because it's digital twins.
Digital twin is very more complex. It's so complex that when 2 years ago when we start to think about that, wow, that's very confusing. This one, what is it all about the digital? When people talk to you about it, but again, yeah. So today you hear us talking about digital twin. During the weekend, you can share with you can Sembang with your friend about digital twin. So this one no longer a big buzzword anymore. Is what you actually know, and then what is happening right now. Actually, more and more modeling how for digital thing coming up. So of course, the last one will be the more of the what they call for what kind of purpose. What is the main usage or application? Yeah. So usually simulation is used for more testing based on some hypothetical formulas. Then you use software to simulate that, to get a result. But what about digital twin again?
Yeah, like you said just now, the simulation one, everything is run within a controlled environment. So all the parameters assumed is the ideal case.
Yeah.
For the digital twins, it's different. So you are getting the data, getting the real-time data, and then and you want to do the decision making is more complex compared to the simulation. Usually, you will involve a lot of AI in behind.
Okay, real-time decision making, optimization kind of thing. You can apply in many ways. If let's say one of the very good example. In fact, when we talk about predictive maintenance, can predictive maintenance be a kind of digital twin? Let's say I have a machines, I build a digital twin of that machine. From this digital twin, can I have predictive, or how can I use the data to drive my maintenance? Do you think it's possible?
Yeah, I think it's possible.
I think digital twin is you can see is a bigger. It covers quite a big areas lah. Predictive thing maintenance is only part of. It can be part of the digital twin. Of course, digital twin can do many things. So, for example, in your machines, you have, for example, a machine. Let's say talk about this molding machine. A molding machine has got a parameter of pressure, temperature, vibration, the time, in time of operating it, that kind of thing. So if I want to build a digital twin, of course, it's not only these few parameters. It may be more about the whole thing, where it sits, the environment temperature, who actually operate it, So we gather data from that and build a virtual model of the machines. But from there, from the digital twin modeling, you can actually find out what are the key things that's affecting. So that's how maybe predictive can be part of the digital twin as well. So okay, I think that part we will just conclude it as now you know the main differences of this simulation and the digital twin. Okay, let's move on to, before we move on to the other part, maybe you want to share something about is there any other thing that you may want to ask the audience? Do you have anything to ask the audience?
I think no for this.
Maybe no. So again, you are watching Jom Les Sembang AIoT. My name is Cecily.
Yeah, my name is Kenneth.
So every Friday we are having this session, talk about technology and so on. Of course, digital twin is a bit far away from us in the real life. You know why? Because digital twin sometimes is so virtual. It's so virtual. It's not so easy to build. Like the other day we talked about the Earth digital twin. Who can think of this Earth also has got the set of digital twin,
Yeah.
of the Earth. So these are the very so-called very far away very far away. But we want to talk about that so that we have some basic understanding about that. So let's when we move along this AI thing, you still understand, all these people is talking about this digital twin. Okay, let's move on from here. Maybe we would like to say, you want to bring out your thing. Yeah. Okay, so it's about IoT and connectivity. Okay. This is a previous slide. Okay, let's. Okay, never mind. So while we are doing this part, so I would like to just bring out. Last time we attended you are the one who attended. No, I came for the first day and then you came in on the second day. That was the forum was organized by something related to AI AI. So that's where he talked about this digital twin. That's when you heard the Earth also got digital twin.
Yeah.
So you want to describe a bit more about that thing?
At the time they talk about using the build a digital twin for the Earth is for the weather forecast. So they want to know how the climate change will affect our human for the next 100 years.
That is a very, very good model. That's a very good example of a digital twin. Digital twin of the Earth.
Yeah. So this one is very important for our future planning. For example, Indonesia government, so they already moved their capital to the Borneo there.
Okay.
So because they already know in the future, their current capital will be submerged into the sea.
Okay. Singapore also facing the same problem. So the land will be.
I think it's the seawater rising.
Seawater rising. So from this kind of digital twin, then you actually able to predict, what is going to happen. But again, this is a digital twin still cannot fight the heaven, the God. In the middle of the day, maybe God want to send something, or this universe want to, you want to create any other thing that we don't know yet, because we are still basing on what we can see, what we something that you still, there are certain uncertain things that you still don't know. Okay, let's move on from here. I think you have another slide, right? Okay. Okay, this is the thing. Why people use paper blueprint in the manufacturing industry. This one we are talking about past. So of course, every of this session right now, for especially the smart manufacturing side, we are talking about something about the past and the present and the future. So these are the things. So maybe you want to talk about that,
So during the old time, when there is no digital twins at all, then how the people do? So everything starting from the paper blueprint. So at that time, because first we lack of the digital technology during that era, so everything is still using the paper. And then you also have the ease of reproduction and distribution. So it's also quite durability and reliability. So because they just draw their machine
on a paper.
Yeah, on a paper, and then
they have to do some try and error.
Yeah.
They put in things to connect them together. So they will do some try and error.
Yes.
Okay.
And then it's a universal communication method. So no matter you are from what background, from maintenance or engineer or architect, so everyone is looking at the same design. So it's a universal communication method for everyone at that time. And then it's also for the legal and record keeping purpose. So that one is serves as some kind of pattern. So because your drawing is describing how you build the entire machine, or how your process is happening. So it has some sort of legal purpose And then it's also convenient for on the site reference. So in the old time, they just put a portion of the blueprint beside the machine, so that the operator or the engineer over there, they can just straight away look at it, so they know how to operate the machine, how to use the machine.
So we can say, in the old days, those people are more intelligent than people right now.
So that one is the fundamental.
Okay, fundamental.
And then they also use this thing for the training and skill development for their new staff. So the new staff need to know how to interpret the blueprint. So actually the blueprint is contain all the information, how the operation in the factory.
Okay. Yeah. Okay. That's the first part.
So how the paper blueprints looks like. So actually it's the technical drawing of your machine part, or it can describe your process. So it usually contains the dimension, measurement, and then what kind of material they use, and the component relationship and the assembly details, how to do the assembly, and then the tolerance and the finishing instruction. And some of them they also include the bill of material, indicating the required parts. So these are the things inside a blueprint.
Okay.
Okay, so we move to the next one. So why the paper blueprint are not used today? Okay, so today we have the digital CAD software.
Okay.
Like the
CAD software. Okay.
Yeah, like the AutoCAD, SolidWorks. So these are the very famous digital CAD software. And then, if you use the digital version, it's more cost and efficiency, less cost, because you can easily update your drawing.
Right.
So if you're using the paper version, you need to redraw everything. It's not easy for you to do some modification. So using the digital version, you can easily do the modification. And then you also improve the accuracy and the precision. So last time you need a very long ruler to draw everything. But now using the software, you can get a very accurate dimension. And then also easy for collaboration and sharing. So if you use paper, you want to share to your other colleague at another country, it takes many days to reach there. But now digital version, you just send an email. It's very easy for you to do this thing. And then you want to store it also easy. Just store in the computer, in the pen drive also can. And integration with the manufacturing system. So this kind of information can integrate with your MES, the ERP things. And then the version control and traceability. This one also very important. Usually across the development period, you have different kind of version. So when you use a paper to do this thing, it's very hard for you to do the, you want to see the difference between the different version. But using the software is more easier.
So for some of you who have just watched us in this Sembang AIoT live channel, we encourage you to give us some comment, and let's say you have, or give us some idea. We want to hear from you. Of course, every Friday we are sharing this part. We talk usually is related to technology. Of course, our key thing is going to be more AI and IoT. AI and IoT. So this is a set of things that we are talking about. So we encourage you to give us some comment. Let's say you have anything. Okay, let's move on to the other part. So right now we are talking about a present moment. What we have right now. So right now we have the digital twin. In fact, digital twin is they're starting to have this kind of digital twin. I think it's maybe how many years ago? I think it can be many years ago, but it will be more popular right now because of the computing power. You have a better computing power. That's why it's easier for us to build a virtual system. That is the thing that we are currently having. So this AI enhanced design and digital twin, of course, you have a generative model of thing right now. Not only very fixed, rigid kind of digital twin, but it's more generative.
Yes.
Okay.
So now the AI can give you a suggestion on how to improve your product design. So it's not no longer being limited by your staff capability already. Now the AI can give you more ideas to improve your product design. And then, the digital twins with the real-time synchronization, like what we discussed on the previous session. So you can get the real-time data and then can know and predict what is going to happen next if you still continue with this kind of parameter.
So meaning, if let's say I have a machine running here, I have another set of virtual, so-called not virtual machine now. Virtual machine become a software already, virtual machine. So it's a virtual kind of physical setup, digital twin setup. So from there, actually, you can do improvement on your common new design. Not only building this digital twin, you can also have kind of generative thing to build a better model of the digital twin. Is that? So that thing is very valuable, So okay, so let's move on from here.
So besides digital twins, now we also have the immersive technology, for example, the VR and the AR, where the engineer that can use this kind of technology to help them to do the virtual assembly, maintenance, and the training. So I think in one of the exhibition we saw someone that used the VR to do the welding, and train their staff to use the VR technology, VR or AR, to do the welding steps.
Okay.
And lastly, what the digital twins want to achieve is, at the end, you can get a virtual factory. So this one is a concept that even before you start building your real factory, you will have a virtual factory first. So this is for you to decide how your production line looks like, where to place your machine, so how the entire flow is going to happen. So to optimize the entire process. So sometimes people, after they build their factory, then they only realize, actually I should put the machine at another side, not at this part. It seems as it's blocking the entire flow. But the cost to move this thing, it might be very high because everything's already start running. So why don't we, before we start building the factory, we do this kind of planning first?
So that is going back to our first question, how actually, if let's say you already have a road map, just a Google map, you have this Google map, you want to go to this destination, of course you'll go through all this kind of obstacle, traffic jam, all those things. So that thing actually is kind of a past data that, of course, Google Map is you have this kind of past data, but then real-time also you have, real-time data. So you actually want to reach that destination, you can use the digital twin model to build the thing that you want. So for example, you have one factory, you collect all the data from your process data, workflow data, produce this kind of production data, quality data, all those things. You have all these things, you can build a digital model. So from there, let's say you want to build another new factory, or you want to relocate, actually from there you can easily plan out what you want to do. So it saves a lot of time, and also you can improve. There are many areas that you can improve, from digital model. You know, let's say I put this area, what will affect my workflow. So this coming back, that is very similar to what we talk about, what call the OEE, you know, planning of OEE on the 6 losses, you know, which model should go first and things like that. OEE is not even the digital twin yet.
Not yet.
Maybe forecasting can be part of the thing, forecasting, forecasting of your plan. Okay. Okay, we have come to the end of your slide, is it? So, of course, today we want to just share with you a very short one. Digital twin. I know digital twin is very far from us. If next time we have a more solid model, because we have during the exhibition, Smart Nation exhibition in the past, or MDX exhibition, we met quite a number of so-called this digital player, So they are building on the smart building digital twin model, and then smart city digital twin model. There are so many digital twins. So of course, one part is very important that without data, you are not able to form a digital twin at all. So that's why we are promoting industrial IoT. We are promoting IoT. IoT talk about what? IoT talk about the connectivities. In order for you to gather all this data, you need a good connectivity. Of course, you need a good sensors to bring in the kind of data that you want. So more and more data, more and more what it calls sensors that allow you to gather things that you want. Don't talk about let's say talking about air. You have humidity, temperature, everything. So you're talking about a machine. You have a vibration, temperature, pressure, strain. Sometimes the strain, and also talk about energy consumption. Those things are you are able to build from there. So people, workflow, movement of vehicle, or those things you are able to build. That's why with all this data, digital twin is able to form quite so-called cost efficiently to build that kind of thing, because those things are available. Plus, with the AI modeling, more and more advanced AI modeling, I think digital twin can be can be more affordable. In the past, I think it should be using by those Fortune 500 companies. Not a small company you can tap onto it. But in the very near future, I think you can see more and more companies. So with that, I think we want to end our session today. I thank you very much for watching us. So before we forget, we have me and Kian Leong is doing training as part of our what we call task, yearly tasks, so-called. So we always keep on to that. Both of us are HRDC accredited trainer. So what we do is we provide some training. So of course, in the training we talk about fundamental things, we talk about technology, and very important thing is we do bring up some practical thing or applied cases to talk to you, and then to give you a training about that. So it's kind of very hands-on training on the IoT and also AI. AI part, there are two sets. One of them is more of a computer vision. Currently, it's moving on a computer vision. So we just want to let you know, especially for you, let's say you are in Malaysia, we have this under HRDC, Human Resources Development Corporation, we have this Rise Forward 2.0 funding. It's a fully funded grant that gives to all the SME to attend this training. So the grant is very limited. So if let's say you think your friend or you yourself in your factory that you require this kind of training, it's entirely FOC. You can scan the QR code. Inside there are some eligibility, all those things there. So you can scan the QR code. And then you connect with us. We will put you up to there. So if you have a chance, we see you at the training floor. So, okay, so with that, I think we want to wish all our Muslim friends again, Selamat Hari Raya. So enjoy your Raya, and we see you next week. Bye-bye.